Earth's orbit, the ideal point of observation for studying the deepest mysteries of the universe and gathering valuable data. From this vantage location, the International Space Station is a unique research platform for pushing forward the boundaries of knowledge. Docked to the ISS since 2011, the Alpha Magnetic Spectrometer is the most sensitive particle detector ever deployed in space. It analyzes cosmic rays to find answers to some of the fundamental questions in physics. Slawosz Uznanski, engineer at CERN and member of ESA's astronaut reserve, explains the importance of operating it in outer space.
The AMS detector is one of the biggest fundamental science experiments in space. The main advantage of being on low Earth orbit, it means above our atmosphere. So particles coming from outside of our solar system are directly recorded by the detector before they interact with particles of our atmosphere.
Through AMS's detections, scientists search to unlock some of the secrets of cosmos, such as what is the invisible mass of the universe, which we call dark matter, and what happened to primordial antimatter. In both cases, the technological challenge is very high. AMS houses 8 instruments that measure the mass, charge, and energy of the cosmic particles passing through it. In its first 12 years of operation, the instrument detected more than 223 billion cosmic rays. The process is similar to what happens inside CERN's detectors on Earth. So, what's the difference between them?
AMS is a detector, like the ones, for example, we have in the Large Hadron Collider. For AMS, the particle accelerator is the universe. The universe is the originator and providing particles to AMS. They have very high energies and impact our detector that will classify them, study their properties and their energy.
Among hundreds of different kinds of charged elementary particles, only 4, electrons, protons, positrons, and antiprotons, have infinite lifetimes and they can travel through the cosmos forever. To detect them, AMS uses a large circular permanent magnet, which bends the paths of cosmic particles by generating a magnetic field 4,000 times stronger than that of Earth. The complexity of this instrument comes along with the challenges of operating it in outer space, while being exposed to extreme conditions.
Let's start with the first problem, cooling. On Earth, thermal management, we can give away heat in 3 main ways: convection, conduction, and radiation. In space, we don't have all these options. There is no air, we operate in vacuum. So the real only way to remove heat from the whole structure is radiation. So looking at the dark sky and give away this energy into the vacuum of space. The second big challenge that is obviously generating of power. The AMS was designed to be attached to the International Space Station to benefit from already existing platform, to provide power, to provide communication as well with the ground.
The AMS experiment is the result of 18 years of research and collaboration among hundreds of scientists from around the world under the leadership of Professor Samuel Ting, the 1976 Nobel Prize in Physics from the Massachusetts Institute of Technology. The AMS detector was assembled at CERN and launched from the Kennedy Space Center to the ISS in May 2011. AMS will continue to collect and study data throughout the lifetime of the space station. Except for maintenance or repair periods, the detector operates continuously every hour of every day. All the information is collected within nanoseconds as particles traverse the detector and is then transmitted to Earth through a system of satellites in geosynchronized orbit. The data is received by NASA and relayed to the AMS Payload Operations Control Center at CERN and then shared with hundreds of research institutes around the world.
AMS is a big data source on the International Space Station. As far as I know, the allocation of bandwidth is the highest of all experiments on the International Space Station, around 10%.
In the meantime, the tasks of a CERN engineer and ESA reserve astronaut may one day be combined in a space mission.
Working in space and being an astronaut, I think it was my dream since I was a little boy. As of today, I am in the ESA Reserve Astronaut Corps, and I hope I'll have a chance to fulfill this dream to go once to space and work on such an amazing platform like the International Space Station.